So the experiment today is looking at chemical formulas, chemical reactions and balancing equations. We have a series of experiments for you to perform. Each of those reactions will have a chemical equation associated with it, an equation that you'll have to balance and provide as part of your final laboratory report. The other major factor for each of your experiments is to log your observations for each reaction and tell us about those telltale signs that make you believe that a chemical reaction has happened. So what kind of signs could there be for a chemical reaction that you could talk about in your final report? The reaction could give a change in colour, which might be a sign of a new chemical product which is absorbing a different wavelength of light. There could be the sudden disappearance of a solid chemical in solution, which is a sign of it being used up. Or there could be the sudden appearance of a chemical, which we sometimes refer to as a precipitate. If you can't see through the solution, if your solution looks cloudy, then it's probably a solid precipitate which is blocking the light and preventing you from seeing through the solution. Remember that reactions either give out energy, which we sometimes call exothermic reactions, so the test tube might feel very hot. And some reactions absorb or take in energy to make them go. So as they take that energy in from their surroundings, sometimes the test tube will feel very cold to the touch. There could also be the production of a gas during the experiment. And for your experiments this afternoon, you're looking at the production of 3 specific gases. So the first gas you can test for is carbon dioxide, CO2, a gas that does not support combustion. So you can take a lighted taper, hold it over the very mouth of the test tube and don't go any further. And as that carbon dioxide comes out of the test tube, it should extinguish the flame. The second gas you're going to test for is oxygen gas, which is combustible. So you'll take a lighted splint, blow it out, and along those orange embers on the side of the splint, hold those just inside the test tube and no more. And if there is an enriched oxygen atmosphere being produced by the chemical reaction, that higher oxygen atmosphere should help to relight the splint. Now, this is going to be very hard to catch, and you could see just a very brief extra glowing or brighter flame just for a second before it dies out again. So be very sure to watch keenly as you put that splint in. Again, don't put it too far into the test tube because you'll starve it of oxygen. So for this experiment, we have a bit more specialised piece of equipment for you, which involves those lilac trays. Fill the tray up with water to that little bench plateau mark. So take one of the glass jars, which we're going to use to collect the hydrogen gas, fill it with water right to the very brim, and then carefully place a stopper in the top without allowing any air pockets to form in the jar. With the stopper still in, turn it upside down and place it underneath the water level in the tank, and then carefully take the stopper out and leave the jar underneath the water level upside down. Slide the jar over to where the hydrogen gas is going to evolve, and now get your Erlenmeyer flask ready for the chemical reaction. The chemical reaction is going to be with some zinc pellets. Put that into the Erlenmeyer, then put on the rubber stopper and pour the hydrochloric acid in through the spout through the top. When the hydrochloric acid reacts with the zinc, one of the products formed is going to be hydrogen gas. When you see the tank start to bubble, Let those initial 10 seconds of bubbles to pass through uncollected, because a lot of this is probably going to be air, oxygen and nitrogen gas, which you don't want. So after about 10 or 15 seconds, move the jar over, start collecting the hydrogen and let the jar fill up.
Okay.
Okay, do we blow it out?
Sorry?
Do we blow that out?
No, it's
Okay.
hydrogen you're trying to burn.
Okay.
Blow it up so.
Right. Woo!
Excellent, well done.
Yay!
Now for the first experiment, the combustion of magnesium, we'll need to combust the magnesium in the fume hood at the back of the lab. So your instructor will set that up and each group can burn the magnesium and we'll get rid of the nasty fumes. Just very smoky. For your chemical waste for today, we've got two primary bottles. There's a waste bottle for any chemical reaction that doesn't involve chromium. And then we have a waste bottle for any reaction that does involve chromium. Chromium is a cancer agent and we must keep that separate from the other waste. The majority of reactions with chromium will either be yellow or orange in colour for their precipitate. If in doubt, ask your instructor which bottle to put your waste into.